Hello there, welcome to June 2019 applied paper. Here we're looking at question 8, final mechanics question. A particle P moves along a straight line such that at time t seconds, where t is greater than 0, the velocity of P, which is v meters per second, is modelled as v equals 12 plus 4t minus t squared. Find the magnitude of acceleration of P when P is instantaneously at rest. So what that's asking for us to do is to find acceleration from velocity. So we need to differentiate. dv by dt is going to be 4t, just 4. 12 differentiates to 0, 4t differentiates to 4, and t squared differentiates to 2t. And if it's instantaneously at rest, when P is instantaneously at rest, now that's not going to be when t equals 0. We need to find when the particle is at rest, and the best way to do that will be solving this equation equal to 0. So t squared minus 4t minus 12 equals 0. So solve this, t minus 6, t plus 2 equals 0. So the time there must be 6. Because otherwise it would be minus 2, and t is definitely positive. So we need to plug in now t equals 6, so therefore the acceleration is going to be 4 minus 2 lots of 6, so therefore the acceleration is going to be 4 minus 12, which is minus 8 meters per second. Okay, tricky little question, that one. Moving on to part B, find the distance travelled by P in the interval from 0 to 3. Now, if you've got velocity and you want to work out distance travelled, you integrate. So you can see the difference between the two things that have happened there. To work out acceleration, you differentiate. To work out distance, you integrate. So it's going to be the integral of 12 plus 4t minus t squared dt. So let's integrate now. So it's going to be increase the power by 1 divided by the new power. And that's going to be this on this integral here in between 3 and 0. So we now plug in 3, plug in 0, and do the subtraction between the two. But when we plug in 0, it's just going to be 0, isn't it? It's in this question. So it's going to be 12 times 3 plus 2 times 3 squared minus a third times 3 cubed. And we could probably work this all out without the calculator. 36 plus 18 minus 9, and that's going to give us 45 meters. Let's just check that on the calculator, don't want to give you a wrong answer. 45 meters, yeah, 45 meters. So there we are, that's the answer for question 8, worth 8 marks in total there. Just a reminder of what we've done here. We have distance, we have velocity, we have acceleration. You differentiate to get from one to the other, and if you want to get back from one to the other one, you just do the reverse of differentiation, which is integration. That was the essential part of this question here. So there we are, that's 8 marks in total for this question here. And there we are, that's the AS Maths Applied June 2019 paper answered fully there. Good luck in your 2020 exams, everyone. Otherwise, if we've already done the 2020 exam, maybe you might want to move on to it and now have a go at a few of those questions. Thanks very much, everyone.